Hey guys, just wanted to do a quick video presentation to talk about my research topic, which is the bioelectrical forces of the heart. So there's a few different factors that we have to cover here, and we need to discuss a little bit of anatomy and physiology of the heart, and then we need to talk about the specific different types of cells that are in the heart that make up the heart muscle itself. And then we need to talk about what actually makes those particular cells cause our heart to beat, and the different forces that are affecting that within terms of physics. And then what I really wanted to talk about to get us back on track with physics is how this all relates back to the things that we've been talking about with the millivolts and different amps and everything, because that's really how the heart works, is electrical activity. And so let's jump right in here. So I'm going to use a couple of figures in this book here that I've had for a long time. So I'll switch the camera around when we do that. So two different kinds of heart cells. Your heart is a muscle, and it has some very unique muscle tissue that you don't find anywhere else in the entire body. There are two types of cells that make up the heart muscle. There are myocardial cells and then pacemaker cells. Okay, so when we talk about heart muscle, let me turn this around here so you can see. The heart, this is my mock-up of the heart. Okay, so you have the top layer, the top portions of the heart here. These are the atria, and then these are the ventricles down here. Okay, now blood comes from the rest of the body in here into the atrium, and then it comes down from the atrium and gets pushed down into the right ventricle, and then from the right ventricle it goes to the lungs out this way. All right, to the lungs, and it gets oxygenated, and then it returns into the left side of the heart up here. It comes in to the left atrium, and then it comes down into the left ventricle and then out to the body. This is the bigger of the two sides of the ventricle, the left side, because it pumps all the blood out to the heart, right? And so the left side of the heart is more muscular than the right side of the heart. The right side, all it needs to do is receive the blood from the body and then pump it out to get oxygen, gas exchange in the lungs. But the left side's responsible for your blood pressure, okay? All right, now, when we talk about cardiac cells, there are two that I mentioned. There are myocardial cells and pacemaker cells. And on our diagram here, you can see these outlined in yellow, okay? The heart muscle itself, everything that you see in red, keep in mind this is one-dimensional, everything you see in red is going to be your myocardial cells. Everything that you see in yellow is going to be the pacemaker cells. Everything in yellow has very specific properties based on where it's located in the heart. Okay, so this is what they call the sinoatrial node up here, the SA node, all right? And it's the primary pacemaker of the heart. These pacemaker cells that are in this particular portion of the heart are specific, and they keep a certain rhythm in the heart, okay? And we'll talk about that more in a minute. So then you can see as it comes down in here, in this bundle here, it comes down to the AV node, the atrioventricular node, okay? And that node is responsible for a few different very important properties that we'll talk about here in a second when we talk about the EKG rhythm of the heart and the specific rate of the heart. And then once you go down from there, it's conducted down through these myocardial cells into both ventricles of the heart. This is very specific because blood has to go out the top valves of the heart here and to the rest of the body. So as it comes down, all of these cells are catching the stimulus from these myocardial cells, and it's spreading and squeezing the blood from the bottom out to the top, as opposed to in the top of the heart up here where the blood is coming from the top. And so gravity is primarily responsible for pulling that blood down into the ventricles. But when these valves are closed, when they open, they're almost pulling blood from the rest of the body or from the lungs, depending on which side of the heart you're talking about. And there is a line here. These are two separate chambers. I don't know if you can see that very well. So two separate chambers, but gravity fills this chamber on both sides of the top of the heart. And then the stimulus coming from the nodes and these pacemaker cells in yellow squeeze the blood out, as well as gravity forcing it down into the ventricles. And then the stimulus comes from the myocardial cells, comes from the pacemaker cells here in yellow, and then squeezes it, and it flows out of there. Okay, so myocardial cells and pacemaker cells.